AI agents can use tools, recall vast amounts of memory, and make incredibly complex decisions. So why do they still fail so often? Welcome to this explainer. Today, we're taking an honest, objective look under the hood. We're going to break down the anatomy of AI agents to understand exactly why they break down, and more importantly, how developers actually fix them. Let's get right into it. Here is our diagnostic checklist for today. We'll be moving quickly through 5 main areas: the system illusion, the agent pipeline, where agents fail, fixing the system, and finally, the debugging mindset. All right, let's kick things off with part 1, the system illusion. You know, it's really tempting to treat AI like it's just magic. But here's the paradox we run into. These agents are incredibly capable, right? They can make decisions, pull up vast amounts of information on demand, yet they still frequently do things like pick the completely wrong action, use the wrong tool, or give us answers that are super confident but, well, totally incorrect. So what's actually going on here? The big idea to grasp here is that AI agents are systems. They're absolutely not magic. They rely heavily on reasoning, which is driven by large language models, plus external tools and memory. And honestly, that is their biggest vulnerability. If just one single piece of this interconnected system fails, the whole thing goes down. It's literally like a chain. It is only as strong as its weakest link. Which brings us to part 2, the agent pipeline. To figure out how things break, we kind of need to see how they're supposed to work first, what engineers call a happy path. Think of it like a really busy restaurant kitchen. It starts with you, the user, giving an order. That input goes to the LLM, which is like our head chef, who does the reasoning. The chef then makes a decision. Based on that decision, the system either grabs a tool, like a specialized kitchen appliance, or retrieves a memory, like checking a recipe book. Finally, it plates the dish and pushes out a response to you. That clean 5-step flow is our core foundation. Now let's go ahead and stress test this pipeline. Part 3, where agents fail. So the reality? Failures can happen at literally any step along the way. We're talking wrong decision-making, fumbling the tool selection, tools just flat-out failing to execute, memory problems, or wild hallucinations. But honestly, it usually starts right at the beginning, with poor prompt design. Bad instructions lead to unclear reasoning, and that creates a massive domino effect, cascading into inconsistent behavior and just wrong outputs. Basically, a bad recipe is going to ruin the meal, no matter how good your chef is. Let's look at a real-world scenario to see this domino effect in action. Say you ask your agent, what's the latest AI news? Now, the correct path is for the agent to realize, oh, I need real-time data for this, and then trigger its search tool. But a huge failure point happens right there at the initial decision node. The agent might totally misunderstand what you want and just get lazy. Instead of using the tool, it just gives you a generic, out-of-dated answer based entirely on its old training data. But okay, what if the agent does decide to use a tool? Well, it can still break. It might confidently grab the completely wrong one. Imagine it trying to use a calculator API to answer a text-based search query. It makes no sense. Let's say it does pick the correct search API. The execution itself can still fail. The API might be down, the data could be corrupted, or the response might just come back half empty. And as we move further down the pipeline, we hit major memory and hallucination risks. The agent's memory might just pull up a bunch of irrelevant noise or outdated facts, missing the actual context completely. Always. And we've all seen this. The model might just skip the retrieval process entirely and hallucinate. It just guesses. It gives you the super confident but entirely made-up answer instead of actually looking it up. Okay, so we've broken the system down and found the bugs. Let's shift gears to part 4, fixing the system. The good news is we can actually fix these issues. For port prompting, we have to give crystal clear instructions that explicitly tell the agent exactly when and how to use its tools. If tool errors are the problem, developers need to design better APIs with really strict input and output validation, basically adding verification steps to double-check the work. And to fix that random guessing or hallucinating, we just lower the model's temperature setting to force it to be more consistent and less creative. When it comes to memory issues, the key is filtering. We have to actively filter stored data to cut out the noise, making sure the agent only retrieves the exact context it needs. Ultimately, though, the real fix is combining all of these individual patches into what we call a hybrid system. That means blending the LLM's reasoning with strictly designed tools, highly filtered memory, and hard validation steps, all working together in one robust architecture that constantly cross-verifies its own work. Let's bring this all together in our final section. Part 5, the debugging mindset. Here is what you really need to take away from this. Real-world AI demands incredible reliability because at the end of the day, mistakes destroy user trust. Companies can't just build an agent, launch it, and walk away. They have to treat agent development as a continuous debugging process. It takes heavy monitoring, aggressively testing edge cases, constantly refining prompts, and building real hard safeguards into the system. So if you remember nothing else, remember this quote: AI agents are powerful but fragile systems. Yes, they have absolutely incredible capabilities, but that fragility means they aren't just plug-and-play magic. They require very careful, deliberate engineering and constant iterative improvement to actually work reliably out in the wild. And that wraps up our diagnostic on why these agents fail and how we patch them. Be sure to catch our next explainer, How AI Agents Plan Tasks, breaking problems into steps, where we are going to dive into exactly how these architectures tackle complex multi-stage problems. Until then, ask yourself, as we invite more and more of these AI agents into our daily lives, are we truly prepared to deal with how fragile they really are? Keep learning, and we'll see you next time.